So there are certain things we can do with 2 by 2 matrices that are kind of convenient. This is kind of a cool problem. So what we want to be able to do, though, is to be able to find an inverse. And we're basically going to show you 3 methods. 2 of them only work for the 2 by 2s. And I mean, I guess you could extend it to a 3 by 3, but it's not easy. And then the other method we'll show you is more for a 3 by 3. Okay, but you can use it for 2 by 2s. Okay, so the first thing we're going to do is we're going to say here we have matrix A, and we're trying to find the inverse. So what we want to do is we want to say A times some matrix B. Actually, let's not call it B. Let's call it the inverse. Let's use the notation. So A inverse. When you multiply them together, you have to get I, right? Okay, so what we're going to do is we're going to say A is 1, negative 2, 2, negative 3. We're just copying that matrix. And then we don't know what the inverse is. So we're just going to say A, B, C, D. We don't know what the 4 entries are. That's what we're trying to figure out. But we know when we multiply them that we should get the identity. Now, I'm gonna put a space here. Let's see. I'm wondering how big a space I need. But we're going to go ahead and multiply those. You know what? I'll just erase it. Let's go ahead and do the multiplication. So we're going to go first row, first column. So you get 1 times A minus 2 times C. We'll just write it that way. Then we're going to go first row, second column. So 1 times B minus 2 times D. Okay, I don't need those parentheses. Now we're going to go second row, first column. So 2A minus 3C. And then second row, second column is going to be 2B minus 3D. So hopefully that makes sense to you with the multiplication. I mean, we've been practicing that. So that's the multiplication. But when we multiply a matrix times its inverse, it has to equal the identity. Now, we didn't really talk about the equality of matrices, but if 2 matrices are going to be equal, then each element has to equal the corresponding element. So entries have to equal each other. Like if I'm going to say if A equals B, then Aij has to equal Bij for all, ij, for, each one. So what that's saying is I need to say this has to equal 1. So I'm going to say that. 1A minus 2C has to equal 1. And then I can also say, well, B minus 2D, so 1B minus 2D has to equal the 0. It has to correspond to the element in the first row, second column, okay? So like we're saying A11 has to equal, if this were B, that would be B11, okay? And then A12 has to equal B12, and so on and so forth for each element. Okay, so there's 2 equations. Now let's go to the green ones. So 2A minus 3C has to equal 0. And then 2B minus 3D has to equal 1. Okay. Now, what we're able to do is we're able to solve a system of equations. So you kind of have to change your thinking over to what we were doing in 7.1. And how do we solve this? Well, I'm just going to use the addition method. So see how I have a pair of equations here? That's what I'm going to work with. I've got A and C in both equations, and I'm going to work to find A and C. So I'll use the addition method. I'm going to multiply the top one by negative 2. So I'm going to get, and that's the whole equation. So I'm going to get negative 2A plus 4C equals negative 2. Make sure I did my multiplication right. And then I'm going to add that to the green equation, 2a minus 3c equals 0. So I'm going to add those together, and I'm going to get those are canceling. I'm getting 1c equals negative 2. Okay, great. I know what c is then. I know c is negative 2. How do I find a? Well, I'm going to take that orange equation up at the top, that 1a, which is bugging me to write 1a, so I'm just going to write a, minus 2c equals 1. So I'm using this equation right there, okay? And now I'm going to plug in c, which I know. C was negative 2. And so I get a plus 4 equals 1. Kind of running out of room. I just needed a little more room. A equals negative 3. Okay, so now I know what C is, and I know what A is. I just have to find B and D. Okay, but I have another pair of equations here. BD equations, right? Okay, I'm going to use the same method. So I think I'll go ahead and just cancel the B's. So I'm going to multiply by negative 2. And so I get negative 2b plus 4d equals 0. Okay, make sure I did that multiplication right. Negative 2b plus 4d, 0. Okay, then the green equation, I'm just going to copy that down. 2b minus 3d equals 1. Now I'm going to add those together. The b's are going to cancel, and I get d equals 1. Now you could have a lot of questions like, why did you eliminate the b's? Why not the d's? And you could have done the d's. That would have been fine. You're just solving the system of equations. These are two equations with two variables like we did in 7.1. So you could go back and review 7.1 if you need to. Okay, so d equals 1. So pick an equation. I think I'll just take this green equation this time. 2b minus 3 times 1 equals 1. So 2b minus 3 equals 1. 2b equals 4. And so it looks like b equals 2. Okay, so we found D and we found B. We already knew A and C. So what is the answer? Well, we were trying to find the inverse, and we had made the inverse, A inverse, we used variables A, B, C, and D, right? Okay, so we're going to say A inverse equals, now we know A, B, C, and D, so we just have to put them in the right spots. Negative 3, 2, negative 2, and 1. Now you can check that by multiplying A times the inverse and see if you get the identity. But I'm not going to check it, but you could. Okay, so that's one way you can find an inverse of a 2 by 2.